Miniature steam, hacks, hints and tips. And this is the first episode, part 1, ceramic gas burners. And the first gas burner to look at is a Bix burner. This is one that I bought recently for a 504 boiler, but they do have a tendency, if they're not set up properly, to go into cremation mode. If a gas burner is not burning correctly and it's in a confined space, you can get a carbon monoxide problem, so I do recommend that in your workshop or wherever you're working with gas burners, you have one of these. This is a standard carbon monoxide alarm. I'm not the best person to speak to when it comes to reading instructions. I generally get on with it, and when I get stuck then I read the instructions, but with a Bix gas burner you must read the instructions. To adjust a ceramic burner like this, you need to move the position of the gas jet in and out of the venturi relative to the primary air holes. You can see them in the left hand side of the clip. It's a popular misconception that ceramic burners should glow red. They shouldn't, because if they do glow red, they're going to overheat over a period of time. When I move the position of the gas jet in and out relative to the air holes, sometimes it starts to glow red and other times it looks blue. I made this gas jet holder. It's simply a piece of hexagon turned down and a hole's been drilled down the centre which is threaded 1BA to accept a commercial gas jet, and the gas jet I'm using for this test is a number 12. The main problem is it's very difficult to see what the status of the flame is unless you do this. Just turn out the light and set up the gas burner in a dark room, and you can then clearly see what's happening with the gas. This, by the way, is completely wrong. The gas jet is pushed too far in and the gas is hanging around like a pool on top of the ceramic, and the flame is yellow. And that's no good at all. When I turn the light back on, you see what I mean? You can't really see that it's not burning properly. It looks okay, mainly a blue flame. But turn the light off and look at it. The unburnt gas is sat on top of the ceramic and the flame is burning yellow, which is incomplete combustion. By moving the position of the gas jet, you will see what happens. The pooling disappears and you start to get lots of little triangles. Now this is what we need. Lots of small blue triangles really means you've got lots of very small blue blowtorches like this. And as I move the position of the gas jet, you can see what's happening. As I move the gas jet in and out relative to the holes in the venturi, the ceramic burner changes from being a carbon monoxide generator like this, with a very poor flame that's about to turn yellow, and if I touch one of the air holes, I get a very sooty yellow flame, and this is no good. You need to have lots of little blue triangles. The flame will burn much hotter if you do it this way. But beware, if you pull the gas jet out too far, most of the ceramic will start to glow red. And when the burner is placed in a confined space underneath the boiler, for instance, it's going to cremate. And once again, the health and safety warning, make sure you're doing this in a very well ventilated area. So do it in the evening when it's dark, because you have to have the door or windows open. What I'm doing at the moment is moving the gas jet in and out, and this is cremation mode starting. Proper cremation mode is accompanied by a strange roaring noise coming from the burner and a white deposit all over the underside of the boiler. This is because the fire has gone into the inside of the burner and is just cremating the ceramic. I'll relight the burner and I set it like this and it looks great. I mess about with the position of the jet and then it goes wrong. And to recap, this is what happens when the gas jet is pushed too far into the venturi hole. As I pull the gas jet out of the venturi away from the air holes, I have to wait for a short while until the gas stabilizes. I think this is as good as I can get it, but still I have to wait for a while for it all to stabilize. I can see a little bit of yellow flame creeping in. The best thing to do is to turn the gas off and wait for a while, then relight. And readjust the settings from cold. Now that the ceramic has cooled down, you can see that initially the gas is pooling at the right hand side. So before moving the gas jet and chasing my tail, I'm going to just see what happens. And I can see traces of red in the middle coming on, which is not what I want. I want it to be all blue if possible. So I'll fit it back underneath the boiler and see what happens. This is a shot of the gas jet underneath the Stuart 504 boiler. And now it's in a confined space, it's burning differently. So I need to pull the gas jet out of the venturi just a very slight amount. By setting up a Bix gas burner this way and making fine adjustments once it's in place, you will get a cleaner burn and no chance of a cremation. The setup procedure for the round burners is exactly the same as I've just described, so I'm not going to do it twice. All you do is slacken off the pinch bolt and move the gas jet in or out until you get the required type of flame from the burner. But don't forget, read the instructions that came with the burner before using it. Here's the burner fitted inside the boiler, and as you can see, lots of blue triangles with a bit of red. And when I have the gas jet too far out, this is what happens, it all turns red. This, over a period of time, and it wouldn't take long, would go into cremate mode. This is a Max Steam burner, made by my friend Mike Abbott at Max Steam. Mike wound up the business a while back and decided to retire. Mike and I used to talk about gas burners now and again, because they're a bit of a pain really. This was a later revision of a Max Steam burner and it was unsuccessful. Mike had great difficulty, as do I, in getting hold of the correct type of ceramic. This type of ceramic cremates very easily. And I made this ceramic burner work by fitting a different piece of ceramic. This is the stuff that you need, it really is good. But it's very difficult to find. Just by chance I bought some via eBay. But there were only 2 pieces of this type of ceramic available, and I do believe it came from a Valor gas fire. So if anyone knows where I can buy this stuff from, I would be very grateful to know. Please don't confuse it with the stuff that's currently available from China online. This ceramic is quite different, and it's very different from the stuff that Bics use in their burners. It's much better. And this sort of ceramic doesn't suffer from the cremation problem. This is the other problem with ceramic burners, the howling that you get in a centriflue boiler. And also, incomplete combustion is often a problem. The smell that comes out of some centriflue boiler chimneys is horrific. I modified the Max Steam burner to fit in this boiler, but whenever the burner was pushed all the way into the hole, I got the howling noise. And I found I got much more heat by just pulling the burner back a little way. In this clip you can see all the very small blue triangles, which means you have many small blowtorches on the burner head. This burner is very successful in the application that I'm using it. This is a boiler that supplies steam to a Stuart Victoria, and it supplies too much steam. I can turn the burner down to next to nothing, and here's the burner with hardly any pressure at all, and it's just a nice orange flame. There's no bad smell from the chimney, there's more than enough heat to boil the water, and it's an ideal situation. The other thing, of course, is it's completely silent. In days gone by, centriflue boilers were often fired by paraffin or petrol blow lamps. Gas is more convenient and a good bit safer, really. Having a tank full of pressurised petrol on the bench is not something I really want to do. This is a piece of the same ceramic that I bought that came from a Valor gas fire, apparently. And I built this into a burner for a model steam launch. Normally, any gas-fired steam plants that I have use butane as a fuel. I buy these medium-sized cans of camping gas, that's gas with a Z. But for a small model boat, I buy the propane-butane mix canisters. These are commercially available items for picnic stoves and things like that. As the gas mixture in these small canisters is a mixture of propane and butane, it's mainly butane with a little bit of propane, the gas in these canisters is at a higher pressure than a normal can of butane. So this is a good and a bad thing. First of all, you get a very fierce flame and it's good. But then in no time at all the canister chills and the pressure drops, and it's not so good. And it makes it difficult to set up gas burners. The question being, do you set up the gas burner with a full tank of new gas that's not chilled at high pressure, or do you set up the gas burner with a tank that's been running for a while, so the gas pressure is much lower owing to the chilling of the tank? The butane that I use is in a large canister, so it doesn't chill so badly and remains fairly constant. When I set the gas jet position for this burner, I left the tank on for quite a while to chill before I got the final setting right. This type of ceramic material that comes in rectangular blocks, and it's the stuff that I've just mentioned that I can't get hold of, never seems to suffer from the cremation problem that you do get with certain types of ceramic burner. And I think it's just down to the design of the ceramic. This stuff is very knobbly on the top, and it must distribute the gas or direct the gas away from the burner. Here I'm just testing how much heat's coming off it, and it's considerable. In no time at all the blade on my craft knife, my very blunt craft knife that lives on the bench, is glowing quite red. This burner provided quite a lot of heat and soon boiled the water in the boiler that was sat above it. Well, that was until some particles of dirt got into the gas jet and blocked it up. That's another story. Often in these commercial gas canisters there's some bits of rust from inside of the tank, and if this gets into the gas jet, it blocks it up, and the burner won't function properly until you unblock the gas jet using a suitable gas jet pricker. As I was testing this burner in the workshop for quite a long time, I ran a complete can of gas through it. This happened. This is an excerpt from the video as it happened in real time. And then the carbon monoxide alarm goes off, and when that happens I generally stop what I'm doing and go outside the workshop and take the carbon monoxide alarm with me to reset it. My workshop, by the way, is not a sealed room. It's a double-length garage and the garage door is fully open. But I'm cutting short the review of this boiler because I'm too young to die. I'm evacuating the workshop and I'll go and have a cup of tea until the carbon monoxide level subsides. Carbon monoxide is extremely dangerous. Please take notice of what I've just shown, or the piece of ceramic will not be the only thing being cremated. Thanks for watching, and I hope you found it useful.